In this video, we are going to be learning about inclined planes. There are two main forces we care about acting on inclined planes. There's the normal force, which acts perpendicular to the plane, and the gravitational force, which acts straight down. However, we don't care about this component of the gravitational force. We care about the component of the gravitational force that is parallel to the inclined plane. So these are your best friend forces when working with inclined planes. I would write these down on your formula sheet. The force going straight down the plane, which I call F down, is equal to mg sine theta. And the normal force, Fn, is equal to mg cosine theta. Let's take a look at where these forces actually come from. Here is a box sitting on an inclined plane. Gravity goes straight down. That blue line represents the force parallel to the inclined plane, or going straight down the inclined plane. So this red line is the normal force. So this red line would be the negative of the normal force. Now what we should notice is that this angle is actually the same as theta. And then this blue line again is F down. So what we can do is, if we take the sine of theta is opposite over hypotenuse, so that would be equal to F down, I'm just going to say FD, over FG. So if you solve for F down, you get FG sine theta. So that's where FG sine theta comes from. Remember, FG is the force of gravity, so that's just the mass times gravity. So FD equals mg sine theta. Now, what happens if you take the cosine of this angle? Well, you would get adjacent over hypotenuse. So you would get Fn over Fg. So if you solve this for Fn, you would get Fg cosine theta. And remember, Fg is just the force of gravity. To get the force of gravity, you just do the object's mass times gravity, so mg cosine theta. You will not need to know where these forces come from exactly or how to derive them for a test, so I would just memorize this and this, or at least have them on your formula sheets. Let's do a few sample problems. A 0.5 kilogram wet bar of soap starting from rest slides freely down a ramp 2 meters long, inclined at 6.8 degrees. A. What is the acceleration of the bar of soap? B. What is the normal force acting on the soap? So we always want to do these problems by visualizing it. So here's our bar of soap on the inclined plane. So there's only a couple forces that we care about. There's mg sine theta, which is pulling down on the soap, and then the normal force, which is mg cosine theta. Now, there's really only one force that is causing the object to move, and that is mg sine theta. And as we know, F equals ma. And then the force is mg sine theta. So we have F down equals mg sine theta equals ma. Now, since we have an m on either side of this equation, can simply cancel out the m, and we get g sine theta equals a. G is 9.8 because we're on Earth, and theta is 6.8 degrees. So we get that A is equal to 1.16 meters per second squared. Don't forget units. Then we're looking for what is the normal force acting on the soap. So based on what we just learned, Fn equals mg cosine theta. M is 0.5, g is 9.8, and theta is 6.8 degrees. So if you just plug that all into your calculator, you should get that the normal force is 0.993 newtons. Again, don't forget units. Alright, here's sample problem 2. A cord holds a 15 kilogram block stationary on a frictionless plane angled at 27 degrees. What is T? What is Fn? What would the acceleration be if the cord is cut? So, for part A, this block is just stationary. So T is pulling that way, and mg sine theta is pulling the opposite way. Because this block is stationary, we know that T must be equal to mg sine theta. So all we have to do is solve for mg sine theta. So the mass is 15, g is 9.8, and then theta is 27 degrees. So F down is equal to 66.7 newtons. Don't forget units. Now the next part of the problem asks us to find the normal force. So the normal force is mg cosine theta. M is 15, g is 9.8, and theta is 27. If you solve for that, you get that the normal force is 131 newtons. Now part B of the problem asks us to find the acceleration. We can solve that really similarly to how we solved part number 1. So if the rope is cut, there will only be one force that we care about. Let's actually take a look at that real quick. If this rope is cut, the only force that we care about acting on this mass will be mg sine theta. So F equals ma equals mg sine theta. Again, you can cancel out the masses. A is equal to g sine theta. And you get that A is 4.45 meters per second squared. Don't forget units. Now, you could solve this a different way. Remember, F equals ma, so you could just do 66.7 divided by the mass of the object, which is 15, and you should get the exact same answer. Last sample problem. This skier has just begun descending the 30-degree slope. Assuming the coefficient of friction is 0.1, calculate his acceleration. Notice we're not giving the mass here, which must mean that it can cancel out at some point. So in this problem, there are really two forces that we care about acting on the skier. There is mg sine theta, and that's a horrible looking theta, but whatever, pulling down, and then there is kinetic friction pushing up the incline. So the net force acting on the object is going to be mg sine theta minus Fk. Remember, the net force is equal to ma, so we set all that equal to ma. Now, remember that Fk is equal to the normal force times the coefficient of friction, which is that number. Now, the normal force on an inclined plane is not equal to the weight. It is equal to mg cosine theta. Mg cosine theta. So F down is equal to mg sine theta equals mg sine 30 degrees. So that'll be 4.9 times the mass of the object. All I did here was I did 9.8 times the sine of 30 degrees. Sine of 30 degrees is 1/2. 1/2 of 9.8 is 4.9. So again, this m doesn't stand for meters, it stands for the mass of the object. Then we have to find the force of friction. The force of friction, again, is the coefficient of kinetic friction times the normal force, and this is the normal force here. So we plug that into here, and mu k is 0.1. So we have 0.1 times mg cosine theta. If you take the cosine of 30 degrees, it's around 0.886, and if you multiply that by 9.8, and then multiply that by 0.1, you get that Fk is 0.8487 m, and again the m stands for mass. Now remember, we need to do F down minus Fk equals ma. So that would be 4.9 m minus 0.8487 m equals ma. What do you notice here? Each term has an m, so we can divide the whole thing by m and cancel all these m's out. So you end up with this, 4.9 minus 0.8487, and you get that A is equal to 4.05 meters per second squared. Make sure you don't forget units. You should have written these sample problems down. Make sure you have those in your notes.